Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video I am going to discuss how you can use AWS Athena as data source for your Apache Spark ETL pipelines. Okay, so nowadays many companies use AWS Athena for running ad hoc queries, especially the data analyst team members use Athena very frequently to analyze the raw data from S3, and similarly there are data engineering team members who basically use that same data for writing Spark code to apply complex ETL transformations, right? So the question obviously many times comes in this kind of data analyst and data engineer where both are working together in this kind of work environment. The question comes, can we read the data in a Spark data frame directly from Athena table? Okay, that's the question. Okay, maybe we will be running one SQL query in Athena, and whatever result set we will be getting, that we want to feed in our data frame, which is written in Spark, that is PySpark. Okay, and the answer is yes, it is possible, and here is the architecture to do so. Okay, maybe your PySpark is running in EMR cluster or Databricks, this kind of environment. Okay, what we can do from this cluster, from the simple Python code, we can call the PyAthena API to run one SQL query in Athena. Okay, and Athena has a default feature that whenever it executes certain query, it writes the result set in an S3 location, right? Now directly from PySpark Athena table reading is not possible, but PySpark has no problem to read the result set of that SQL query from S3, right? So we can do that way. So the flow will be like, first we are in PySpark, we will be basically executing one SQL query using PyAthena API. What is PyAthena? PyAthena is nothing but a Python package. Okay, you can simply install by executing this command pip install PyAthena. I'll be showing you, no need to worry. Okay, so using PyAthena, what we are doing here, that we are running one Athena query, okay, on Athena tables, and that result set obviously we can configure where it will be storing in S3 location, and from the S3 location we can read out in our PySpark data frame. That's it. Only thing we have to remember that if you are using EMR cluster, then this particular PyAthena stuff will not come as default installed package. So we need to do one bootstrapping for PyAthena for EMR cluster, and apart from that, obviously when we are starting our execution in that Athena table from EMR Python or PySpark environment, then to make the connection there are two options. One is AWS access key secret key based, but that is not required, because if we are in the same AWS environment, what we can do, we can use IAM role based authentication. So to avoid user ID password based authentication and to run SQL queries in Athena from EMR cluster, we have to make sure that the EMR EC2 default role has the Athena access. Okay, that is another very important point, right? I'll be displaying all these concepts. So without any further delay, let's directly jump into the lab section. Okay, so I have told you, right, that this is the documentation page and installation, all these stuffs you'll be getting from here. I will be basically sharing this particular link in the description box or in the comment section so that you can go through that. Okay, now what I did in the S3 location, I created one particular bucket having this name, and I uploaded two CSV file having same schema. Okay, and then I went to Athena, I created a database, I created a table in that database having the name hello CSV, and as you can see here I have specified the schema. This dataset what I have taken is nothing but simple IDs dataset, which is widely used in machine learning data analysis related project, kind of hello world dataset we use, right? So that one only I used here, ID sepal and sepal with petal and petal with and class name. Okay, and then here what I did, I specified the location. Okay, that is, this is the location, right, this bucket, so that we have specified. And then if I simply do select star from hello world dot hello CSV, that is database name dot table name, here we will be getting the complete data. Okay, here you can see class name is Setusa and versicolor. Only these two categories are there. Actually in IDs dataset there are three categories, Setusa, versicolor and Virginica. I have not taken Virginica. Okay, that's not a problem. So just I have created this table to show you the demo. Okay, right? And then I created another bucket. Okay, what you can do if you don't want to create another bucket, what you can do, you in the same bucket you can create separate folders and you can structure your project. Okay, that is also fine. But for this demo I created another bucket having name logka, and here I have created two folders. Okay, one is Bootstrap scripts. Okay, So as I have told you that PyAthena will not come as default installed version in EMR PySpark console, so we have to do Bootstrap. So for that Bootstrap script we will be storing here, and whenever Athena query will be running from EMR cluster or somewhere, it will try to write the result set somewhere, right? Where it will be writing the result set, that one we will be basically writing in this folder, Athena output storer. Currently if you see, this is empty. I will refresh and show you both locations. So everything is empty. Okay, right? Perfect. Now without any further delay, let's go to the code. Okay, first I will show you in native Python what is happening, and then I will launch an EMR cluster and show you. Okay, so as a first step, what we are doing here, we are installing PyAthena. Okay, and then here from PyAthena import connect. This connect will be using to create the connection between our this particular environment and the Athena. Okay, and here I am importing one more stuff. What is this dict cursor? I will be explaining after some time. Okay, just bear with me. Now here what I am doing, AWS access key and secret key. Why I am taking this? Because I am running the code from Google Colab. Google Colab is outside AWS, right? So we need to provide AWS access key and secret key. Otherwise this PyAthena connector can never understand with which Athena we want to connect, right? So for that what I will do, I will go to security credentials, and here I will go to access key, download key, and here we got this access key and secret key. I'll be taking that. Perfect. So here we have taken access key and secret key. Okay, right? Now here see how I am creating the cursor. Okay, first I am calling connect with this parameter, AWS access key and secret key you are providing, then S3 staging directory. Okay, you will understand in better way soon when I will show you the actual code, but as of now you can understand like this way. This is the location where we have to write the Athena query result set, where Athena query result set will be written. That location we have to specify here. Okay, so for that, here I have told you, right, that this is the folder what we have created. I will go to property section, I will copy this URL. Okay, and that I will paste that here, and then region I am taking US East 1. Why? Because all these stuffs I am doing experiment with US East 1, that is North Virginia. So here I have specified the region name. If you are working in some other region, you can specify that. And then here we are creating the cursor, as simple as that. Okay, right? And then here what we are doing, we are executing the query select star from hello world.hello.csv. Whatever in Athena we tried to execute, that same query I have taken here. Okay, I will just hit enter, and then here we will execute cursor.execute query. It is same like how we do in Snowflake or in other database, right? So I will just run this one. Okay, and see here it ran successfully. And if you see this diagram, as soon as we are running some queries, what will happen? Athena will write the result set in S3 location. Which S3 location? That location what we have configured here. So let's go to this location and see whether Athena is written or not. Okay, so if I go to this location, if I go to object, currently it is showing nothing. I will refresh and see here one CSV file and metadata file are stored. Okay, now if you are working with pandas, or if you are working with PySpark, your point of interest file should be this CSV file. And how we can know the name? That's an interesting point, because if we know the name or complete path, then from there we can read the content using pandas Dataframe or PySpark Dataframe, right? So for that it is very simple. Here you can execute cursor.output location. Okay, in the output location, in this particular variable, the cursor output will be stored. Okay, so if I just run, here you see s3://logga Athena output storer is the folder, and see this particular file is nothing but, if you see this file, okay, this file name and here this file name are same. So that means once you execute your SQL Athena query, okay, using this kind of API, cursor.execute PyAthena, then all you have to do once the query execution is done, you just use cursor.output location to read the content, and from there you can easily read the CSV data. I will show you that also. I will just go here, and here I will download this. Okay, let me just open the file and show you that it is basically containing this kind of data. As you can see here, point to be noted, first row is header. So when you are reading from Spark Dataframe, you have to specify option header true, Okay, like that. So right, and the rest of the data is exactly same what we actually received in our Athena, nothing new. Okay, I can close this one. Right, now suppose you don't want to read in pandas Dataframe or PySpark Dataframe, you can obviously use normal functionalities like database for row in, cursor, print row, okay, fetch one, fetch all these functions are available what you can read from documentation. Okay, so if I just run iterate in the cursor outcome, that is for this cursor, once its execution is completed, if I just run here, I will be getting one by one all the results set. Okay, and it is coming like tuple. Inside tuple, individual column elements are stored. Okay, you can read this one and process it. Another approach widely used in many companies is basically dict cursor. What is dict cursor? The only thing is here you can see that the outcome when you are iterating row wise, we are getting a tuple in a list kind of format, right? But if you are using dict cursor for creating your cursor, you will be getting dictionary format instead of tuple, and that will obviously increase the readability, because from here it is hard for us to understand for which column the value is coming, or for this one for which column the value is coming. If we know this schema, that's fine, we can map. But in the other kind of situation, if I show you only this dataset, it is hard for you, right? So instead of this kind of tuple, you can basically get the result set at dictionary also using dict cursor. So let me show you that. So here I am creating the cursor, only extra parameter I am passing cursor class equal to dict cursor. Okay, and here we have imported that dict cursor also from pyathena.cursor import dict cursor. Okay, right, we are creating the cursor, same stuff we are doing, select star from this table, executing that, printing the output location. So this time we should see a new output location. Okay, so here if I go here, currently you will see that only two files are there. One is actual CSV file, one is metadata file. Next time when I will run that query for dict cursor, two more files will be coming. One is actual CSV, another one is metadata for that CSV. Okay, and output location should point to the newly created CSV, right? So I can just run this one and show you the demo here, and error occurred output location. Okay, I think something is missing. Okay, here staging directory we have to mention. I will just copy from the earlier location only what I specified, and then here I will go and here I will paste this. No need to worry about a single line of code. All these codes I will be providing in the description box or in the comment section. Okay, so if you see this time when I'm iterating row wise, here you will see that the complete data is coming as dictionary format, right? Earlier it was just giving us a tuple format, now it is giving us dictionary format. That's the only difference. And here for other methods, obviously you can explore the documentation. I am not going that much detail, right? Just only discussing that part, what is required for us. Okay, so if you see here, I have printed the output location. Here you can see this time it is pointing to a new CSV file. Currently we are getting 786, but earlier we are having something 006, starting with 006. Okay, if I go to this location, if I refresh, here you will see that two more files are created, and this is the newly created file. You can see, compare the timing also. This is basically 127, this is 131, right? So now all you have to do, once you get the location of the SQL query execution result set from cursor.output location, you can use Spark API to read the data from that location. That's it, right? So now I will show you how we can read and play with Athena data directly from Spark. That is how for Apache Spark we can use Athena as data source. Okay, so for that what I will do, I will launch an EMR cluster. But PyAthena pip installation we have to do in EMR cluster, including master node and all the worker nodes, right? So for that, obviously one option is bootstrapping. What is bootstrapping? How to do that? Regarding all these concepts I have already explained in my previous video. I'll be sharing the link of my previous video in the description box. You can have a look if you want to know the detailed explanation. Okay, right? So here let me show you the bootstrap script. It is very simple. All I am doing, pip install PyAthena. Okay, I am using sudo so that no access issue will be happening. Now this script I am saving as emr_bootstrap.sh. Now let me upload this script in a S3 location, which one we will be using while launching EMR cluster. Okay, so here bootstrap scripts I have already created. I will just upload. So EMR bootstrap.sh, I will upload this one, and it is uploaded. Okay, right? So this S3 location is very important. This S3 location we have to mention as bootstrap action while launching our EMR cluster. Okay, so let's do that. So here I will go to AWS Management Console, and here I will simply go to EMR, and here I will go to cluster, go to advanced option, and here what I will do, I no need Hue or Pig, I need Spark. Okay, and keeping all other properties default, I will go to next, right? And then here master node is extra large, fine, but course I can reduce the configuration to C1 medium, right? And then here I will go to next. Okay, logging this location is fine, debugging termination protection is fine. Okay, I will go to next, and here I will be using an existing EC2 key pair to do SSH in the cluster. Okay, right? I think Bootstrap action I have not configured. Here Bootstrap action is there, right? So here I have to specify custom action and configure. I will be going which Bootstrap script it should run. It should run this one. Okay, so this is the custom action. What the EMR will do, execute that, and while executing in all the nodes, worker nodes, master node, everywhere, this PyAthena will be installed. So we'll be having no issue in executing PyAthena from PySpark. That's it. Okay, I will just add this one. Okay, and then here I'll go to next, and then here I'll go to create cluster. Okay, so let's cluster spin up. We have to wait little bit. Currently it is in starting phase. Let's wait for a couple of seconds. So see, currently the state is changed from starting to bootstrapping. That means it is executing that bootstrap script. Okay, so see, now the state is changed to running. Soon it will be in waiting state. Already 6 minutes elapsed. Once it is waiting state, what we will do, as you can see here, PyAthena bootstrapping is done. We have to provide this particular role Athena access. Okay, so that without using any access key and secret key, we can connect with Athena from PySpark in EMR. Okay, so as you can see, our cluster is in waiting state. If I go to this particular cluster, here you will see that it is using EMR EC2 default role. So we have to add Athena access to it, because in default role it is not there. So there are two options, either using user ID password, which is not a good option. So we'll be using role based authentication. So I'll be going to IAM, and here I'll go to roles. I will search that role, and here I'll be adding Athena full access as of now to it. Okay, right. And another thing we have to do, that is we have to give access to do SSH in the master node. Okay, so for that I will go to inbound rule, and here I will add all TCP as of now anywhere from IPv4 access I want to grant. Okay, later we can find here, not a problem. Perfect. So here I will be copying this public DNS, and then here I will open putty, paste that DNS. Authentication, already one PPK file we have used for configuration, the same one I am trying to use here. Yes, and login as default login ID is Hadoop, right? So I'll be using that. I will just increase the font little bit. Okay, fine. Now what I will do here, I will enter in PySpark. Okay, and here is our PySpark code, what I have written. So first what we are doing, we are importing PyAthena connector, and dict cursor I am using, but you can use normal version also. And then here we are creating the cursor. We have to specify the staging directory. So whatever we used in Google Colab, that same directory I will be using here. Okay, that is basically this one. And then here we have to give region name also, right? So region name I am doing experiment with North Virginia, so I'll be providing US East 1. and then here dict cursor, we are creating the cursor. Okay, then here we are executing the query that if the class name is id setosha, those records alone we want to get. Like that, any query you can write. Suppose in your Athena database there are multiple tables, you can do join, filter, everything, and the result set it will be writing in a st location. From that st location we have to read. Okay, and now see how much easy the process the PyAthena made. Okay, here where it is writing the result set, that also you no need to worry, that also is dynamic, right? So we can just execute cursor.output location, and cursor.output location will basically contain that location where output is written. Only we have to execute the query before running cursor.location. So I will just execute the query. This also will be coming here. Okay, and that way we will be getting the output location from where the result set has to be picked up, and then here I can do any operation on the data frame. So basically this data frame will contain that data which is basically outcome of this Athena query, right? Okay, so let me execute these queries one by one. See, we have got no error. That means Bootstrap action has successfully done its job. And then here I will do one more time query. This query I want to execute, and then here cursor.execute query I will be doing. Okay, so here you see it is executed. If I go to log location, this is the place. Here you will see just now one more file has got created. Okay, that is, this is the one. Now there can be multiple files if you execute multiple queries, right? You might be getting confused that which CSV file we have to read as part of that Athena query, and that this particular API has made very simple. All we have to do, that is cursor dot output location. If you just do here, you will be getting the output location where this particular query result set is stored. Okay, now we can simply use spark.read.csv because that is writing a CSV data. We are passing the complete location from cursor.output location, and another thing is header equal to true. Very important. Okay, because when I have downloaded the file and shown you that time, we saw that header is there. Even I can show you for this file also. I will just enter in this file, and here I will query with s3 select. If I do the CSV file, that's fine. If I just run this particular query, here you will see that the first row it is coming as header. Okay, so that's why we are mentioning header equal to true. Okay, so that Spark will read accordingly. And if I do that, here you will see that Spark data frame reading is started. Some stages it basically executes. So stage 0 it is running. It is going to take some amount of time, and once that is done, we can do df.show all these operations. Okay, so if I do, we will be getting only information related to id setosha, because that's how we have executed the query, right? That is only if the class name is id setosha, that alone we want. Okay, maybe we can do group by and all other possible operations for our Spark data frame. Okay, if I do group by on class name and execute count, only one row will be getting, because only one class is there, id setosha, which is 50. And as we know, as default value also in our id dataset, there are only 50 values for id setosha, right? So that's pretty much it. I hope you understood how you can use AWS Athena as data source for your Apache Spark data frame. And the key point is this concept, this cycle. First, we will be triggering the query from PyAthena API. Okay, PyAthena will run that Athena query. It will be written in a S3 location. That S3 location will be stored in the variable cursor.output_location. That one we can use to read the data in our EMR cluster. Okay, if it is writing in CSV, we have seen that header is there, so we are writing header equal to. That's it. Okay, and using this simple technique, Athena and Spark integration can be very much simplified, and data analysts and data engineers both can work on same table source. Okay, single source of truth, you can use those tables. Okay, right? So I hope you enjoyed this. All these codes and resources I'll be providing in the description box or in the comment section. You can go through that. And if you find this video helpful, then please like, share and comment. Subscribe our channel if you haven't subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.